recording. All right, so we're doing solids of revolution, which is essentially you're taking something that's two-dimensional and you're going to rotate it around an axis, and then it becomes three-dimensional. So instead of finding an area between two curves, we're going to be finding volume. Something is rotated. Come on board. There we go. All right. So one of the applications is finding the volume of a three-dimensional solid. Engineering and manufacturing use this idea a lot. So one of the, like, when are we ever going to use this things? Like, this is one of the calculus that is used quite often. So solid revolution is the result of solid domain is revolved about a line. You can, they were revolving about an axis, and then as we see, we can rotate it around different lines. So revolution is what you rotate it about. And then we are working with discs today, which is basically a cylinder. So it's solid. And what is today? Thursday. So I'll have you guys on Monday. I think Monday is when we do, we call them washers, not like a washing machine washer, but like the thing that you put on a bowl, like a CD. Looks like a CD, so it's got in the middle. Oh, dang, thanks. Hey.
All right.
Anywho, so we're doing discs today, which are cylinders, and then the next time we'll be working with washers. So we're still going to be showing that representative rectangle, not find area of it. That representative rectangle, this is my axis, this is my rectangle. When you rotate it around, thank you, you create a circle, but because it has dimension, because it has a height, cylinder. So in like two-dimension land, when you rotate it, you get a circle, but in three-dimension land, it makes the cylinder, which is what we'll be finding. We'll be finding the volume essentially of one of them, and then the dx at the end, or the dy, is the stack of them, which helps you find the volume of the whole shape that's being taken. Yeah. All right, so keep in mind, you guys said the words circle and cylinder. So you need to recall that, don't worry about writing this down because it's up here, but the area of a circle is pi r squared. And then when you find the volume of a cylinder, the base of the cylinder is a circle, so you get pi r squared, and then you get times h, right? So it gets your thickness. The height is the dx. Okay, so the height of our cylinder is how many, remember you want your dx to become closer and closer to zero, but we're shoving a whole bunch of them into this volume. And then the pi r squared, that's the area of the circle. The r is going to be the radius of the circle, which is essentially the height of the function to the x-axis or the y-axis, because I think that's all we're rotating around today. So if this was the x-axis, the top of your rectangle would touch your function, the bottom of it would touch zero. So if you did top minus bottom and your bottom is always zero, then the radius of your circle is really just the function itself. So the radius will be represented by your function, f of x. So let me flip to the next one. That's how they came up with, if your figure revolves around the x-axis, you can see that you've got your bounds a to b, and then pi, which is a constant. They've got it inside in the definition, but we can always pull it in front of the integral. And then f of x squared, the f of x represents the radius of the circle, and then squared. So it's always pi r squared. A common mistake is forgetting the square. Okay, so remember that it's really when you take that rectangle and you rotate it, it's representing the radius. So it's pi r squared when you find the area. All right, and then around the y-axis, your bounds, they call them C and D, A and B, but C and D have to be y values. They can't be x values. And then your function has to be in terms of y, just like it was when you did your horizontal rectangles. And then make sure that you have dy on the end. All right, let's do this. All right, rotate y equals 1/2 x plus 1 about the x-axis and find the volume of the solid from x equals 2 to x equals 4. So we're going to go ahead and graph y equals 1/2 x plus 1. It's a linear function. What's the y-intercept? 1. What's our slope? 1 over 2. Turn over. So we got our line. And then it says that we're finding the volume of the solid from x equals 2 to x equals 4. So let's see, I'll use green. So x equals 2. And x equals 1, 2, 3, 4. Make sure it's there. X equals 4. So this, let me get gray. If we were just finding the area of it, we would bound it from 2 to 4, and we would do top minus bottom. You would just do f of x minus 0. You would have your blue minus the x-axis, which is 0. But because we're actually rotating this strip around, it's creating a 3D here. So if you kind of imagine as it's rotating around, it might look like a Reese's peanut butter cup when it's 3D. It kind of goes out like that. So like a Reese's cup. All right, so our representative rectangle, which is going to represent the radius. And don't draw it all the way down because then you'd be drawing your diameter. It's this rectangle that we're turning around the x-axis that's creating our circle. And this one's pretty easy because it gives us our bounds, what we're putting those rectangles in. We don't have to calculate any points of intersection. So volume equals, remember that it's, I'm going to go ahead and write this down, pi times AB of f of x, quantity squared dx, f of x is our radius. On the inside, but we can just go ahead and make ourselves a step and bound in for integration. So we'll have pi bounded from what, 2 to 4. Then the top of our rectangle touches our line, which is 1/2 x plus 1. And then the bottom touches 0. 1/2 x plus 1 minus 0 is just your 1/2 x plus 1. So 1/2 x plus 1. And then quantity squared dx. So you could FOIL it out, create a polynomial that you can integrate. We haven't done this in a while. Let's practice using u substitution on this one. What would we let you do? 1/2 x plus the d 1/2 dx. What do we not have? We don't have a 1/2. So we have to balance in front of the integral with a 2. So instead of just pi, we're going to have 2 pi from 2 to 4 of 1/2 times 1/2 x plus 1 squared dx. And then we replace it in terms of u and du. It stays. We get 2 to 4. The 1/2 and the dx becomes the du. So the 1/2 x plus 1 becomes u squared. We can change the 2 to 4. Just if you want to plug in with u's, you need to make sure that you find your u bounds. If you back substitute in with the x's, then you use your 2 to 4s. Just remember that you can't mix and match. So we can do, so if we have x is 2, then u is 1/2 times 2 plus 1. Did I write that right? 1/2, 2 plus 1. Okay, half of 2 is 1, 1 is. So I'll go ahead and I'll change my 2. Oh, look at that. X equals 4, u equals 1/2 of 4, which is 2 plus 1, which is 3. So we take that. All right, so now we're just purling it. Or in divide, we get u cubed over 3 from 2 to 3. You wanted to change it back to 2 to 4. That's when you could. Here, what 3? Let's type this and bring it in front, and you could have 2 pi over 3 that we would then substitute in and have u to the third. Hang on, I got a little bracket to see action going on. From 2 to 3. Then you d minus your f of a, do that thing, all the algebra without messing up to get a volume of 38 pi over 3. And will become volume cubic units. So the mistake is forgetting the square, that it's a radius squared, r squared, because that rectangle spins to become a circle. It's not just rectangle being stacked. Next one. We have 24 minutes to get through this. Next one, rotate y equals 1/4 x squared about the x-axis and find the volume of the solid from 0 to 3. 1/4 x squared from 0 to 3. So 1/4 x squared, if you plug in a 0, you get 0. So we have 0, 0. If you plug in 1, square it, and multiply by 4, you get 4. So up a little bit. Plug in 2 and square it, you get a 4. And 4, so you get 1. And then a 3, you square it, you get a 9. 9 divided by 4, 2.25. So we're taking that, taking this portion, and you're going to rotate it around the x-axis, so then it becomes so if we're going with the candy theme, the first one was a Reese's cup. This one kind of looks like yes. Object, you can think about what you're finding volume of. And then our representative rectangle, which represents the radius of our disk or our cylinder. So I keep saying the top of the rectangle is touching our function, the bottom of the rectangle is touching the x-axis, which is 0. So top minus bottom just gives you the top. In the future, it's not going to just touch the x-axis. So that's why I keep saying top minus bottom. So, all right, volume. Bounds will be 0 to, and what's in front of the integral? Pi, because we're working with a circle, pi r squared, so pi times 0 to 3. Our function is 1/4 x squared, quantity squared. So you get your pi r squared, and then don't forget your dx. All right, so we have to square the 1/4 x squared. So if you square a fourth, you get 1/4 times 1/4 is 1/16. And then x squared squared, x to the 4th, power of a power. And then dx. So what can we do with the 1/16? Left front. So you got pi over 16 from 0 to 3 of x to the dx. And there's no u substitution needed. You're just ready to power rule it. So add 1 and divide by it, and have x to the 5th over 5. But then that needs to get multiplied by x to the 5 over 5 will get multiplied by 16. Which gives you a denominator of 80. So you're going to have in front for 80 of x to the 5th evaluated from 0 to 3. Plug in the upper bound, the 0 will wipe the other one, and that will give us 243 pi over 80 cubic units. All right, rotating y equals the square root of x about the x-axis and find the volume of the solid from 0 to 1. 0 to 1 on this one. Oh, 0. Holy moly. I'm going to make, just so we can see a little bit better, instead of putting it like to that little guy, I'm going to go, I'm going to call that one. All right, so if you plug in a 0, square root of 0 is, plug in a word on it. Keep in mind, you have to think about how a square root function is curved, because those are the same first 2 points for a quadratic function, y equals x squared, except a quadratic function, you curve like this, like the Hershey's Kiss. That is your square root, so we're curving like a square root function, so make sure that you go ooh, like that. Ooh, like that. All right, so we're finding the volume. So that piece, my gray, I don't know what that is. So that original is kind of looks like what? A Rolo?
Like the caramel on the inside.
Rolos are like cylinders. Slanty cylinders.
It looks like one of those toys you like pop inside out and put on the ground, just pops in.
It does look like one of those, but that's not, I wouldn't want my kid to eat that.
Maybe like
A gumdrop? A dot? No, dots. A milk. Who said snowball? Like the things with the fluffy thing? Like the little powder thing. All right. Right. Oh shoot, all right. Anywho, we're gonna find the volume of that. So volume equals pi in front of the integral. One. So top is the x, which is 0, so top line. Move the square x squared, because it's pi r squared. The x, a and the square root of x squared. There's you x. Power rule it. Squared over 2, evaluated from 0 to 1. You get the 2 in, or if you wanted, you can put pi over 2 in front. Just if my matter. That's the algebra, right? It doesn't matter. And then that one would just be pi over 2 cubic units. So, oh, we might have time for the quiz today. Because some people did their assignment.
I did.
I just want to do it.
Yeah. Then I'll have to do more.
Who cares?
That's
future
news problem.
Promise?
You did say that we'll go next time.
It's on the video.
Okay, on the video. All right. All right. Rotate y equals x squared. About the y this time, so be careful how we spin it. And the volume of the solid from y equals 0 to y equals 4. So y equals x squared from a y of 0 to 4. All right, so 0, 0. Or plug in a 0, 0, by the way. Plug in a 1, you get a y of 1. Plug in a 2, you get a y of 4, which that's the highest y that we need. Crazy. So y equals 0 is the x-axis. And y equals 4. Oh, did I only go? Dang it. Thank you, Creed, for noticing that. I can't count apparently. 1, 2, 3, 4. That would be good. There we go. Well, you're only we're rotating the right half around the y-axis. So you don't have to half to create the full thing. The other part's like that. Woo. All right, so for this one, your rectangle, which is the radius of your cylinder, can't go vertically, gotta go horizontally. And so when it was horizontal, we would say right minus left. So the right end of it is touching the quadratic, the left side of it is touching the x-axis, or excuse me, the y-axis. Remember on this one that your volume formula is pi from c to d of g of y squared dy for this one. So we need to make sure everything is in terms of y. So c and d need to be the y bounds and not the x bounds. So your y bounds are 0 to 4. We plug in x, we have to solve it for x so that it's in terms of y. So if you have y equals x squared, if you were to square, you would, careful not to square root it, so we would get x equals the square root of y, or you could write it as y to the, which one, 1/2 or negative 1/2? Just 1/2. There we go. So it doesn't matter which one you use. Which one do you guys want to use?
With y.
Square root. All right, so square root of y, and because that's your radius, you got to square it. dy. So either way, if you do the 1 power or you do the square root, square that, your power becomes we just have y dy. Add 1 to the power and divide by it. Y squared over 2 from 0 to 4, or you can have pi over 2 times the quantity y squared from 0 to 4, whichever one you want to work with. Working it out, 8 pi cubic units. Last one, best one. Look at how much it is. Yeah,
Y goes to 8.
yeah, but, yeah, the bottom half of the graph, so I'm not really sure why. It's ginormous. All right, find the volume of the solid obtained by rotating the region bounded by y equals x cubed, y equals 8, x equals 0, and around the y-axis. All right, so y equals x cubed is our cubic function. And it says y equals 8, so we've got a horizontal line of y equals 8. Oh my eyes. 1, 2, 3, 4, 5, 6, 7, 8. So that's where we'll stop our cubic. X equals 0, so that's the y-axis. So you're really only going to be graphing half of the cubic. What color do I want? Hold it purple. And then I'll go do that guy in blue. All right. 0 onto the third. 1, 2 to the third. 8. Rotating that around the y-axis. So again, I'll change it to purple. Here we go. So when you're spinning it around the y-axis, they want you to have a horizontal rectangle. The right side touches the cubic, the left side touches the y-axis, which has a value of 0. So when you go right minus left, you're just left with the function on the right. Pi r squared, our bounds will be what to what? What are the, make sure you use the y bounds and not the x bounds. 0 to 8. And then our function is y equals x cubed, but because we are putting it in terms of y, we have to solve for y, or solve for x, sorry, so that we get y. We're going to have to get rid of a power of 3, cube root it, so you can have the cube root, that's ugly, of y equals x, or you can write it as y to the 1/3 equals x. Which one do you guys want to plug in? 1/3. So y to the 1/3, so that's your radius, and then you still have to, because it's a circle, square it, and not dx, but y. Did I put dy on the last one, or did I put a dx? Okay, dy. That's a horrible y. All right, so y to the 1/3 squared, this becomes y to the 2/3. Which is just a power rule. So when we have 2/3 and we add 1 to it, we have to add 3/3. So 2/3 plus 3/3 makes 5/3. And then when you divide it by 5/3, you'll really be multiplying by 3/5. So the pi in front will get multiplied by 3/5. So we'll have 8/5 times y to the 5/3, evaluated from 0 to 8. And then that one comes out to be 96 pi over 5 cubic units. Okay, so pay close attention when you guys do this assignment. It's at the bottom of your page. I didn't teach this last year, so because of COVID. So 2 years ago when I did this, I'm pretty sure I changed the directions from what's in the book. So make sure that you follow the bounds that are stated on the bottom of the sheet. And I think it's on your assignment sheet too. Okay, that way you're not doing more than you need to or something you're not supposed to do. Just do what's on the bottom of the page. Yep. All right, it's 9:18. Oh, darn. I don't think 7 minutes would be enough.